Okay, from here over, we've got some multivariable calculus short on boards. We have, first of all, a couple of things about absolute value that everybody should know. Just examples. Absolute value -7 is 7. Absolute value of 7 is 7. So that's two examples that show what absolute value is. Okay, f of x equals magnitude of x. Make a table, sketch the graph. People did this rather quickly, but some people wanted to, okay, they got this right. -2 and -1 give you 2 and 1. 0 gives you 0. But now, being used to switching the signs, they did it down here and got -1 and -2. And the absolute value of 1 is just 1, absolute value of 2 is 2. It's not -1 and -2. For the same reason, absolute value of 7 is 7. It's not -7. So make sure you understand what absolute value means. But that's very easy to correct if you made that mistake, and I'm sure you already have. Okay, then you graph. Okay, you graph the points and you get something like this. And we can observe that you have a constant slope on this side and a constant slope on this side. Slope on this side, if you do your fundamental triangle, you find between this point and this point, the rise is -1, the run is 1. Between this point and this point, the rise is -1 and the run is 1. Between any two points involving consecutive negative integers, you have a slope of -1. So you have a constant slope of -1 over here, and by looking at the rise and run between any pair of points here, you find that it's always 1. Okay, so slope -1, slope 1. There's our graph of the absolute value function. Okay? Now, it's going to be related to the absolute value function, but I asked, how far is it from -1 to 5? How far is it from 7 to 3? How far is it from -5 to 14 to -17? Well, people pretty quickly told me, well, from -1 to 5, we can count that 0, 1, 2, 3, 4, 5. Okay, it must be 6 units. And we can visualize that. And we can also do what we do when we do a rise and run of a triangle with a fundamental triangle. We subtract this from this, and we get 6. Okay? So from here to here is this minus this, and that's 6. Now, from 7 to 3. People did the same thing. They did 3 minus 7, which is what you do to get the displacement. And they told me the distance was -4. Well, that was pretty good because you got the right displacement, which was -4. But the distance is 4 because distance is never negative. And this might give you a hint as to how you get the distance. What do you do to -4 to turn it into 4? You take its absolute value, don't you? Okay? And then from -5 to -17, well, if you do -17 minus -5, you get -12. That would be the displacement from -5 to -17 because you're going in the negative direction. But the distance is 12, the absolute value of the displacement. So we can say distance is the magnitude or the absolute value of the displacement. So from -1 to 5, the distance is the absolute value of 5 minus -1, and 5 minus -1 is clearly 6, and the absolute value of 6 is 6. So we agree with what we know the distance to be. If you're going from 7 to 3, your distance is 3 minus 7, absolute value. The displacement is 3 minus 7, absolute value of the displacement is then absolute value of -4, and that gives us 4. Okay. And you could do the same thing with -5 and 17, but distance is the absolute value of the displacement. So you subtract where you are from where you're going, you get the displacement, take the absolute value, you've got the distance. Okay, what's the distance from 9 to x? Well, the displacement is x minus 9. So you would say, well, okay, it's absolute value of x minus 9. Can we translate this? Okay, well, yeah, that's it. Displacement from 9 to x is x minus 9. The distance is then the absolute value of that displacement. We don't know what x is. We don't know if x is on this side of 9 or that side of 9. So we could get a positive or a negative. If we do x minus 9 and x is 3, we get -6. But 3 is 6 units from 9. If we take the absolute value, we get the right result. If x is 15, then, well, 15 minus 9 is 6, and that is the displacement. It's also the distance, because the absolute value of 6 is 6. Now, translate this into an equation, this statement. The distance from x to negative 3 is 5. Now, people did pretty well with this, okay? Not everybody got it, but everybody got something close. They had an absolute value of something equal to 5. Let's be careful, though. Okay, from x to negative 3, we subtract where we are from where we're going. We get negative 3 minus x, okay? And so the absolute value of negative 3 minus x is equal to 5. Now, we could say, well, the distance from x to negative 3 is the same as the distance from negative 3 to x. Distance between 2 points is the same whichever direction you go. Displacement is different, but the distance is the same. So we could say it's x minus negative 3. Absolute value of x minus negative 3 would equal 5. And again, we need the absolute value signs because we don't know which side of negative 3 x is on. X is a variable. It could be anywhere. And of course, x minus negative 3 gives us x plus 3. So we could also write this as absolute value of x plus 3 equals 5. And we could write this as absolute value of x plus 3 equals 5 also, because whatever the absolute value of negative 3 minus x is, if we multiply negative 3 minus x by negative 1, it doesn't change its absolute value. Okay, if we multiply a number by negative 1, that changes its sign, but the sign is not important for the absolute value. So if we multiply negative 3 minus x by negative 1, we get 3 plus x, or x plus 3. So we get this equation if we rearrange this one, or if we simplify this form. Okay. Now we look at absolute value of x plus 7 equals 4. And you're asked to interpret this in terms of distance. So this would say the distance between what and what, etc. Okay, and people did quite well with this one too. Not everybody got it totally right, but everybody was on the right track. So we'll come back to this in the next clip.